Hi everyone, and welcome to our video on graphing limacons. So we left off on the last video graphing a cardioid. So we didn't know that at the beginning, maybe we could have, but I stated it at the end because we get a heart shape. Well, a limacon always has this form where it's some constant plus or minus a multiplier with a trig function. All right, so here we've got a cosine one. Well, I'm going to do these all the same way, where I'm going to just set up the polar part of it. Okay, so let's make that plenty big. So here's 0, pi halves, pi, 3 pi halves, and then 2 pi. And then what I'm going to do is rewrite it so that I can see it as y and x. Okay, so I've got y equals 2 plus 3 cosine of x. Again, it might help to remember a little bit about the cosine function. So I put sine up there. Let me put cosine with it now also. Cosine does that shape. Okay, so there's y equals cosine of x for one full period. So there's 2 pi. Here's pi. Where it crosses is at pi halves. 3 pi halves, 0. Amplitude is 1. So we have 1 and negative 1 on the y-axis. Okay, so anyway, so there it is. And we want to take that and it's a transformed cosine graph. All right, so we'll make the transformation. So this is saying you should go up 2. So that's up 2. Okay, so 1, 2. And then I think it's best to just draw a new axis. And then here this is saying the amplitude is 3. Okay, so this is a multiplier. Okay, so stretch it by 3. Okay, so times, let's say amplitude, I'll just say it like that. I'm going to do it the old way from graphing. So amplitude is 3. So that means from the new axis, go up 3. So 1, 2, 3. And then go down 3. 1, 2, 3. And then now we'll draw our cosine curve. Okay, so positive. So it's up there. Let me label this. This is 1, 2, 3, 4, 5. And then 0, negative 1. And then we'll draw our curve the best we can. Sometimes it can be nice to plot the points first. Okay, so I'm just trying to make the generic cosine curve, and then now let's graph it. Okay, so it might be good to draw the curve first and then mark those. Okay, so I chose to mark them first. And then here's where 2 pi is. Here's where pi is. Where it crosses the dash line is where pi halves is, and where it crosses the dash line is where 3 pi halves is as our angle. Okay, and this is the x-axis. However, we would be saying, well, in our polar form, those are the angles. So let's just instantly say it really can become theta for our table. So I like to do them both, where I have a graph and a table. And then we said the y-axis is really just r. So the y-axis, I'm going to mark it down here, is r. And we're just going to convert those. Okay, so our first point, r is 5. The angle is 0. And we'll mark it there. Our second point is r is 2, and the angle is pi halves. Our next point, point 3 here, our r is negative 1, and our angle is pi. Our fourth point, r is 2 again, and we're back to or our angle is 3 pi halves. And then our final point, we're back up to the peak up there, which has a radius of 5, and the angle is 2 pi. Okay, a lot of preliminary work done. Now that we've got it though, we can do our polar graph. Okay, so let's start doing that one in blue. Okay, so this is our first point, 5 and 0. So remember, it's saying go to the angle 0 and then count 5 toward it. So 1, 2, 3, 4, 5. Okay, so there's our point. Making a big plot. So that's our point number 1. And then our second point. Okay, and we'll compare it in a second with our graph. Our second point is 2 and pi halves. Okay, so here's our angle pi halves, and it's saying go 2 toward it. So 1, 2, and then we can plot our point. Okay, and then we want to see, well, how do I go from point 1 to point 2? Well, to do that, that's where this graph comes in handy. It's looking at this region. So this is quadrant 1 information between angle 0 and angle pi halves. And we can see our radius is always between 2 and 5, or more importantly, we could say it's positive. So positive r. So that means all the points that we would have plotted should be in quadrant 1. Okay, so that means connecting 1 to 2 should be with some circular arch thing like that. So it's, and we're always connecting these points with some type of circular-ish shape. All right, now moving on, step 3. Our third point, -1 and pi. Okay, so -1 and pi, so here's pi. +1 would be going toward it. -1 though is the opposite way. So that means it's right here. So that's our third point. So now we need to figure out, well, how do I connect 2 to 3? Well, notice in our graph, our other graph, here it is in the blue, it goes from a positive radius to a negative radius. Okay, so once it crosses the x-axis, we have a negative radius. Okay, so some unknown angle, so we don't have to find the actual angle, but it is an angle between pi halves and pi is where we would have r equals 0. Okay, so we get a middle point in between where we have 0 and some random angle between pi halves and pi. So I'm going to say quadrant 2 theta, like that. Okay, so we know that point is there. So we have a preliminary, or we have a point in between. So I'm going to call it star point. So our star point should be through the pole. Again, if you ever have a radius of 0, you're instantly at the pole or at the origin. Okay, so there's our star point. And it's in between step 2 and step 3. All right, well, let's continue to break it down. To get to the star point, I'm going to use green. To get to the star point from 2, notice I would be in quadrant 2. Okay, so this in the green is quadrant 2 information. And it would be positive r because I haven't gotten to 0 yet. So quadrant 2, positive r. So that means connecting 2 to the star point, I would be only plotting points in quadrant 2. So it should be some circular arch like that. Okay, and then afterwards, from the star point to 3, let me do one other color. Let's do it in this pink. So from star point to 3, I'm now still, well, I'm still in quadrant 2, but the radius is negative. So quadrant 2, negative r. So that means those points, because of negative radii, should be plotted in the opposite quadrant. So they should be plotted in quadrant 4. So that means to connect the star point to 3, I should be plotting points in quadrant 4 like that, like how I just put some dots there. And then, well, they should connect with a circular type of arch. And then there we are. Okay, so we got it. Okay, so we connected point 2 to point 3. And then now we need to connect, continue it going. All right, well, our fourth point is 2 and 3 pi halves. Okay, so here's 3 pi halves. 2 as a radius would be, well, count 1, 2. So it should be right there. So there's the fourth point that we should be plotting. But again, I need to figure out, well, how do I get from point 3 to point 4? Well, the one good thing about these graphs is they are symmetrical. You could say, well, I think I can figure it out from here based on symmetry. But if you don't see it, we can still break it down all the way. I'm going to do the green and pink again. Okay, so from, and purple, so I got lots of colors going now. Here again, it crosses from a negative radius to a positive radius. So this is another point where I have 0, but it's some quadrant 3 angle. All right, let's call this point the, I don't know, something like that. Or, I don't know, let me change that. Okay, so I don't like that swirl. I'm going to call it double star. Okay, so our double star point has a radius of 0. It's the point in between step 3 and 4. Okay, so that means it is back to the origin. So double star back to the origin from 3 to 4. All right, let me get my green going again. It first is a negative r. Okay, so that I'm marking in green. I know I'm in quadrant 3, but I would currently have a negative radius. So if I'm in quadrant 3 but a negative radius, that means those points should be plotted in the opposite quadrant. So they really should be plotted in quadrant 1. So that means I should have some points just like these little dots connecting point 3 to the double star point through quadrant 1. Like that. And then now that I've got that part done, I'm going to go back to the pink and say, well, now I'm still in quadrant 3, but my radii are positive now from the double star point to point number 4. All right, so that means I can connect my double star point to point number 4 through quadrant 3 with some circular arch. And then now finally, the last one. Let me go back to blue. Okay, so from point 4 to point 5, I'm only having positive radii. I'm in quadrant 4 with positive radii. And I need to connect it back to 5 and 2 pi. So here's 2 pi, and then 5 means I'm back to the start. Okay, so that means I should have a circular arch-like shape, something like that, back to my original starting point. And there we go. Okay, so there's our final graph. So this is a loop. I'm going to plot over it in black ink the best I can. Okay, so missed a little part of it. It's hard to trace over with a computer, but it's a loop. So that is this case. That's this one. Okay, so because our magnitude of A was less than the magnitude of B, so 2 is less than 3, and we get a loop out of it. Okay, so but that's it. Again, I don't concern myself with those. Again, if you want to, you can. You still need to be able to get like full points though, or like accurate with where the radii should be. Okay, so if you just said, oh, 2 and 3, I know that's a loop, and you draw something like that, I mean, that's good, but where's the scale to it? So we need to know, like, do you know how far that goes and where those points are on the axes? Okay, so keep that in mind. All right, so anyway, keep it steady, short and steady. Okay, so thanks for watching. We'll do the last variation of it in the next video coming up. So see you then.